Hey, what's up, people? First off, this video is pretty much like an addendum to TEF 122, the video in which I opened up and tried to see if I could do a repair on this large UPS that I have the board of right here on the bench. So if you didn't see that video, some of the stuff in here probably won't make much sense. So if you're interested in seeing that one, I'll leave a link to it up there in the Who's It What's It up on the right. And yeah, you can go watch it there if you're interested. So I didn't expect to be here talking about this UPS board again, like anytime soon or like even at all. I had pretty much like written off this thing and said like I'm pretty much not going to do anything with it. I might use it for parts or whatever. But a few things happened since then that have me sitting here once again with some new hope that it may be possible to get this thing up and running again. And so in this video, there's three things that I'd like to present. And the first off is in the previous video, I mentioned that I had tried to like search for schematics for that UPS and that I'd come up like empty handed. So I think the problem I had introduced when I was looking for schematics is that I was being a little too specific in looking for the exact model of UPS that I have, and that just didn't work. The thing is that many UPS units, like the one I have, they were manufactured with different specs, but they used the same board, and the board was populated with the relevant components to handle the amount of power that the UPS was designed for. So what I did then was I started looking for the part number of the board itself, which is this one right here, this 640-0734K, and this is a revision 13 board. And when I did that, that's finally when I started getting some results. Unfortunately, a lot of the images that I found were like pretty low quality images of the schematics, and I didn't find any for this specific revision 13. I did find some for revision 12, and one of the ones that I found was on this scribed website here. So this is for a revision 12 board, and here, as it shows up on the website, it looks somewhat okay. Although if you try to like zoom in, it just keeps like shrinking it down, so you can't get like any good detail. Right there is probably like some of the best detail you can get, but everything is like illegible. You can't really tell what like some of the component values and stuff are. And so I even tried to just take like screenshots of the schematics there, so I could at least like have some reference, and I could use this to like mark up like where bad components were and all that sort of thing. So even though this isn't great, it was at least like kind of give me an idea of how things are supposed to connect and all that. And so since I had found this, I went back to the video that I posted, and I made a comment there about how I had found some schematics and that it would give me, like a good idea of, what was going on up here, and that, I possibly might revisit this in the future again. And immediately after I posted that, I saw that viewer, Howwow. I'm not entirely sure how your name's supposed to be pronounced. I'm probably butchering it, and I'm sorry. But they left an awesome comment informing me that there was a PDF on the EEV blog site of a different but extremely similar UPS board. And that's this one right here. This is for a 640-0735G revision 7. The text and diagrams are so sharp that you might poke an eye out if you magnify this a little too much. So with this, it's easy to compare between the crappy schematics and these good ones here to identify like differences and other parts that may have been used in this new one that weren't used in the old one, and like vice versa. So like for example, there's a double pole single throw relay that's used in this particular board, the 0735G, that on like the board that I have, they use a single pole double throw. And so like this relay here, it's being used to switch looks like the neutral line. Not entirely sure how it's all connected together, but on the newer board or on the later model board, they're actually using it to completely disconnect the neutral and the live from like the rest of the circuitry. So having this nice schematic here, we can actually scroll down here and see what those two mystery components were that are on the board that were marked APC 2010, and this is APC 2020B. So this brings me to the second thing that I wanted to talk about. Now that we know what these components kind of are and what they're supposed to do, we can now more easily analyze what the extent of damage may have been and what components may have been affected. So the two bank of MOSFETs that fried and exploded were this one and this one. And some of the transistors that burnt up was this one right here, this Q29 and Q28. And the resistors that we saw on the board that were burnt were R38 and down here R43. We also saw that IC17, which was 2010B, also was the one that had that black stuff on the side. And that one there does not appear to control the gates directly of the MOSFETs. Oh, and that brings me to another thing. I realized that in the previous video, I kept calling them the base of the MOSFETs. That's if we were talking about transistors, but on the MOSFETs, it should have been gates. So like all the gate resistors and all that stuff is what I should have been saying. But yeah, like I kept saying base. So just a minor little correction there. Right. So yeah, this one here does not appear to be driving the gates directly. It looks like it's tied into it, but it appears that the actual driving is done by the 2020B ASIC right here. And we can actually see right here that this says that it's a bridge charger ASIC. So this chip here is doing the switching between either driving the transformer or rectifying the output from the transformer to charge the batteries. So it can pretty much change its operation like on the fly. So that's how it's able to be an uninterruptible power supply. This chip right here appears to be an H-bridge driver. As we can see, it's got an upper one out, a lower one out. That would be for driving like the gates of the MOSFETs on one side of the H-bridge. Then it's got the upper two out and lower two out, and that would be driving the second side of the H-bridge. But these are not being used, as we can see. So these are going out into the second IC. So what I think is happening here is that this one is probably helping to do some of the synchronization to the line frequency. We see right here, we got the sine ref, and that's the one that's going into this IC. So I think that's how these two are working together to produce the output 60 hertz. So if we take a better look here at how the gates of the MOSFETs are being driven, we see that we've got a basically like a half H bridge here with these transistors in pretty much every bank of MOSFETs. And so one would be used to pull the gate low, the other one would be used to pull it high in order to turn them on and off. And with the exception of the lower side MOSFETs, these, the upper side ones, all go through another little MOSFET to switch these transistors on and off, as we can see there. But they all go through a Schmidt trigger inverter. And that was one of the other ICs that was on this board, like in this position right here. You can see I've already removed it. So none of the gate drive circuitry is actually connected directly into this IC. And unless this hex Schmidt trigger inverter is damaged in some way, it's possible that this IC is totally fine, that it might not be damaged. Now we do see that some of this gate drive does go into the APC 2010 IC. I don't know what it's doing. All I see is that one's connected to LGD2, the other one's connected to LGD1. I'm guessing that probably stands for like lower gate drive, but it appears that this IC is also monitoring the output to the transformer somehow. We see we have here transformer 1 and we have transformer 2 right here, and those are connected directly to the lines that go to the transformer. So what we could do here is we can test this hex Schmidt trigger inverter chip and see if it's damaged at all. If it's not damaged, then that means that the chances of this chip here surviving are extremely high, in my opinion. And it seems that if we replace the bad transistors, which in the case of this, I would probably just end up swapping all of them out, like all of these 2N2222s, the 2N2907s, and all these 2N7000s that are in this section. I just swapped them all out along with all the MOSFETs and the burnt resistors. And if this chip is damaged, I mean, we can replace that as well. If this chip is damaged, then the chances of this chip here being damaged go up as well. I mean, this one here, we could pretty much tell that it was damaged for sure. And one other thing that could have happened if this chip here got damaged is that some of that like very high 48 volt voltage could have been coupled to the 12 volt line. which feeds several ICs on this board. Like, for example, this one here that's used to interface to the back DB9 connector. And as we can see here, it goes to several other places like this LM393, some other transistors and stuff. But another thing that is powered using this 12-volt line is the fan on the back of the unit. And the fan itself was actually working. When I would plug this thing in, even though I couldn't turn it on, the fan would run, and it was running fine. So it's possible that the high voltage didn't actually make its way over here to the 12 volt, or if it did, maybe it was just brief enough that it didn't do any permanent damage to anything else. But as I said, I've already removed the this hex Schmidt trigger IC, which is the 40106, and we can actually, I thought we could test this out using this Giku T56 tester that I recently got. So we can go up here into a device, logic test, and we just got to go up to 4106 right here. But I've got to put the chip in the tester here, so I'm going to put it in the orientation that it shows on the diagram, which is right there. And let's see what happens when we push test. Test failed. So we'd see this and we'd think, well, okay, so this chip is bad. Well, check this out. So this isn't the only IC that I pulled off of this board. That board actually has two of these 4106s. So I tested the second one with the same method, and when we click test, it also fails. So I thought, okay, fine. So both of these are bad, and it looks like maybe that 12 volt made its way over to the, or the high voltage made its way over into the 12 volt rail and damaged a little more than, we would have liked it to. Well, I have another 4106 in my bin of parts, or bin of ICs, and if we pop this one in and run the test again, it also fails. So I thought, all right, what gives? Well, we can see here that these are labeled 74C14s, which are basically the same component, but it's a TTL version, and these would only be running at 5 volts. But on this board, we actually have 12 volts going to these ICs, so they had to use the CMOS version of them in order to be able to handle the higher voltage. So I'm going to take this off of here, and I'm going to pop in a 74C14 in that same position, and let's test that and see what happens. All right, we're going to leave it as a 4106. Hey, normal. And right here it says that it's testing it at 5 volts. So this 74C14 is testing fine. And we can also test it as an actual 74C14 down here somewhere. Where is it? Ah, yeah, there we go. Let's test it as that. And it also passes. So then I thought, well, that's odd. Let's take this off of here. And let's just bend this one of the pins upwards here. So now that we can test to see if it actually is testing properly or not. Let's go back to the tester, test it. Now we see that we've got one that failed, one gate. So it appears to be testing correctly, but the 4106s all fail for some reason. So I thought, well, let's take an older tester, and this is my Mini Pro, and let's set this one up to test a 4106. Well, let's look for it here on the list. 40, 40s, 4093, 4160. Oh, no, we don't have a 4106. But we do have a 7414. So let's just select that. Let's, first of all, let's go ahead and test the 74C14. I'm going to bend that pin back so that it can test it properly. Lock that in. Let's hit test. Hey, test result, normal. Okay, so let's go ahead and take that one out. Let's test the one that I pulled out of my bin of ICs. Lock that in. Go back to test here. Click test again. Hey, test result, normal. Cool. Okay, let's take that one out. Let's test the one that wasn't in line of all the other components frying. Lock that in place. Test it again. Normal. All right, so let's take that one out. Test the one that was part of the gate drive circuitry. Pop that in. Test it again. Normal. So is it possible that this chip is actually working and it's not damaged? Well, one of these two units is lying to us, and I don't know which one it is. So I decided, well, let's rig up a test then and see if this chip is working or not. So we can take it out of here. We can pop it into the little spot here that I've made for it. And what this is going to do here is I have a set of dip switches over here on this side. Now, when these dip switches are up, and we're only using 6 of them because there's only 6 gates inside of this IC. And then I have a set of 6 green LEDs and I have a set of 6 red LEDs. So when these are up, that means that the switch is off. The wires here that are going into the inputs of the gates are going to be pulled up high. So that's going to be a logic 1, which means that the opposite side, we should be getting a logic 0, which is going to be pulling this side low. And when this side is low, it's going to make the green side of LEDs here light up. When we flip a switch on, now it's going to allow ground to be connected to the inputs of the gates. And that's going to mean that the output is going to be high because now we're getting a logic low input, and these are inverters. So now that we're getting a high input, we should be getting the red side here to light up. So we'll be able to test all 6 gates inside of this IC and see if they're functioning or not. And I have not tested this myself yet, so I don't know what I'm going to get. And I am going to test this at 12 volts, so I have a little jack right here that I'm hooking up to a 12 volt power supply and making sure that all these switches are up. And I'm going to plug in power here now. And since these are all up, we expect only the green side to light up. So let's see what happens. Okay, so far it seems to be doing what it's supposed to do. We have a logic 1 input, we have a logic 0 output. So since these are all connected to positive, it means that they're all going to light up when their other side pin is pulled low. So let's start turning these on and off one at a time, starting with the first one. We're going to push it down, and that's going to simulate a logic 0. And here it goes. There it goes. That went low. Or, I mean, technically the output went high when the input went low. Next one. Oh, that works. Oh, that works. That works. That works. And that works. So this IC appears to be working properly. And you can see that these are still kind of glowing a little bit. I think that's just because of the arrangement I have it in. That's not having anything to do with the actual IC. But yeah, let's go ahead and switch these back up. And yep, we're getting the exact results we'd expect to get from a working IC. Just to be a little thorough here, let's go ahead and test the other chip as well. So this is the other 4106 that was on the other part of the board. And let's go ahead and hook up power to that. And there we go. Let's switch these off. There it goes. So yeah, both of these chips seem to be fully functional, and it doesn't look like the 12 volt line was affected in any way. So since this IC appears to be totally fine, chances are this chip is fine as well. All I would have to get is a replacement APC 2010 and replace all the other components over here and the MOSFETs, and this thing might work again. And getting one of those APC 2010 ICs is probably not going to be an easy task. And I really don't want to risk buying one from a potentially, questionable website or anything like that. And that brings me to point number 3. And this involves a little bit of a story. Now, I mentioned in the previous video that I had taken similar units apart like many years ago. And I kind of kept those boards around in my junk bin for, parts and whatnot. And 5 years ago, when we were moving into the house that we live in now, I was cleaning our old garage and going through like all my junk bins and, parts and all that stuff and deciding what I was going to keep, what I was going to let go, and, just kind of setting stuff aside and all that. Well, I had these 2 huge transformers. One was from like a really old school like BuzzBox welder, and another one was from a large car battery charger. And I did not want to be lugging those around during the move, and so I decided to just give those away. And so I put them up on Craigslist in the free section, and they sat there for a couple days. If I had like no biters, then I was probably just going to end up taking them to like a recycler or something, because like I said, I did not want to deal with those heavy things. And when there was like a few hours left of when I was planning on taking them down, some guy emailed me on Craigslist asking me if I still had those transformers available. And so I was like, sweet, I don't have to worry about doing anything with these things. he left his information. I got a hold of him and I told him that, yeah, I still have him. He asked him, where I lived and all that. So he comes over, he picks them up, and I think he noticed that I had like a bunch of stuff in the garage, and it looked like, we had the for sale sign up in the front of the house and all that. And so he was just, doing a little chit chat and stuff. And he asked, are you getting rid of anything else? And I said, actually, yeah, I'm just going through my stuff and I'm like setting a pile, of stuff that I'm going to get rid of and, what I want to keep and all that. And he said that he'd be interested in picking up some of the stuff if I was just going to get rid of it. I said, for sure, dude. Like, I'll see what I've got. I'll set it all aside and then I'll let you know when I'm done. And he said, all right, cool. So, he takes his Transformers. He's on his way. And I continue working on sorting out like everything. So I think like another day or two went by and I had like a massive stack of stuff. And I call the guy and I tell him like, there's a lot of stuff here. Don't feel obligated to take it all. It's like way like too much stuff. And he says like, oh no, I'll take it all. I don't care. And I was like, all right then. So he comes over, he loads up his little truck that he brought, which looked like it needed shocks like ages ago. And as he's about to leave, he goes, well, my wife won't be happy, but I sure am. So he leaves our driveway. This truck's just like swaying side to side from all the weight. He takes all the stuff. He's on his way. And he did let me know that, if I ever need anything back, just let him know or whatever. And I thought like, why would I need any of this back? In that stack of stuff was about 5 or 6 of those old UPS boards that I had taken apart. And I remember that they were very similar to this kind of board, but the layout was a bit different because they were smaller UPSs. But they did have like a big 40-pin IC like this one. They had like a bunch of other smaller ICs. And I don't know the exact numbers of any of those or anything like that. But they came to mind after I got a hold of those schematics. And I thought, man, I wish I still had those boards laying around. And then it hit me. Do I still have that guy's information in an email? So I did a search on my email for like anything that was related to Craigslist. And sure enough, I found one email. And it was the one where that guy was asking me if I still had those Transformers. And it had his phone number on there. So I thought, well, I'll try to hit up the guy and see if he answers, if he even still has this phone number or anything. And I called the phone number. Sure enough, he answers. So we're having a little conversation and I'm telling him, trying to remind him, but like, about the time that he came up to pick up those Transformers and all that junk stuff. It took a little bit of describing everything because I'm pretty sure he's not the only one he's picked up stuff from. He started to remember. And so I told him that the reason I was calling was that it was a long shot, but I just wanted to see if by any chance he still happened to have those old UPS boards that I had thrown in that pile of stuff. And, if I could like maybe pick up a couple or something, I even offered to pay him. And he said like, oh, no, you don't have to pay me or anything like that. I'll see if, what I can do. So then he asked me to describe them. And so I'm sitting there describing them. And I told him that I found an image online and I could send it to him of what it looked like. He said that, he'd take a look and see what he could do. He said that he's got, bins of stuff and he may have to do some digging, but he tried to look. So I emailed him the picture and he also wanted me to text it to him. So I sent it to him. And he replies back saying that, yeah, those do look familiar. And so that he'd check for me and see if, by some chance he still happens to have them or not. So as of right now, that's pretty much where we're at. I mean, I'm not going to pester the guy, like every day or anything and ask him if he found them or not. I'm just going to wait to see if he gets back to me. And if he finds those boards and I'm able to get a hold of them, we might be revisiting this thing and actually trying to repair it. I'm not going to hold my breath because I don't want to get my hopes up or anything. But for the time being, I am just going to set this aside. I'm not going to order all the MOSFETs and any of the other components until I know for sure that I can get these ICs. Like I want both that APC 2010 and possibly the APC 2020B, even though I don't think that this one here may have gotten damaged in any sort of way. And yeah, that's where we're at. There's a little bit of hope that we could potentially get it working. And so that's where this video here is going to end for now. It could be a month or two or more before I can get to it, but we'll just see what happens. So with all that said, thank you guys for watching. If you watched the previous video, also thank you very much for doing that. And I will see you guys around the bench.